So yesterday we completed with, am I audible, students?
Yes, ma'am.
Yes, ma'am.
Okay, okay. So yesterday we completed the third module, right? With the yesterday we deal with the assignment problem, right? I have shared the video along with the PPT in the Google Classroom, so you can go through it. And I have told that the next Wednesday will be the deadline, right, for the assignment. So kindly submit it too. Okay. So today we can start with the fourth module. In the fourth module, we'll be having two things, that is constrained as well as unconstrained. Okay, that are all the two main things which are there, among which the under the unconstrained methods we'll be having optimization methods, we'll be having the direct search method as the first topic. Okay, so in the case of the direct search methods, there are also indirect search methods too. We'll be dealing today with the direct search method. Okay, so in the case of the direct search method, from the thing itself we can know about that it is a search method. Okay, so that what are all the ways in which we can complete it. So nowadays what we are dealing with here,
Excuse me, ma'am.
optimization. Okay, so
Ma'am,
based on, yes,
can you give the class code, ma'am?
okay ma, at the end of the class you remind me so that I can
Okay,
provide
ma'am.
you again. Okay, is it okay?
Okay, ma'am. Yes, ma'am.
So we are having the direct search method. So from the thing itself, we can that is we can know that it is the search method which is there, and based on the search methods, what we are going to do, we will be optimizing. Okay, so for based on the optimization, what are all the direct search methods which are there? That is what we are going to see here. Okay, in the case, normally the real world problems, there are certain problems which are a non-linear one, that is it may be variant. Okay, it is not a linear one. Then some other things will be a complicated thing, right? So, in the basis of the non-linear problem, what we will be doing, non-linear optimization, for which we will be checking with some non-linear mechanisms and we will be implementing, because we know about this may be the, we can predict that this may be the solution which we are going to get, and this is the way which we need to proceed. Accordingly, we will be proceeding. Okay, as in the case of the complicated thing, it is not so. We can't predict this may be the thing and this may be the accurate result which we are gaining. Okay, so for which what we are supposed to do, we will be giving an objective function. Just the objective function is given, and based on the objective function we will be doing certain strategies for the same, and we will be proceeding with that. Okay, and we will be reaching with somewhat a similar answer which we are getting. That is how we will be doing in the case of the complicated thing. Okay, so now in both the cases we can't find a analytical solution. So what we are doing, we will be going for a that is possible solution. What may be the possible way in which we can attain it? Okay, so based on that, what we are going to do, we'll be using certain search algorithms, and based on the search algorithms we'll be implementing. Okay, this is how the real world problems are categorized and it will be performed and the optimization are carried out. Okay, now we can see about the flow chart. Okay, so based on the flow chart, what is the things? At first we will be starting with the trial solution. Okay, we will be starting with the trial solution. It is given that xi, okay, What is xi? It may be the input which is there in the thing. Okay. So some variables are given as the values of xi. Okay. Now what we are supposed to do, we need to compute the objective function. So objective function is a function of the variables or the trial solution which is there. Okay. Now what we are supposed to do, we need to generate new solution. Okay. We need to generate the new solution. So for generating the new solution, what we are supposed to do, we need to take into concern the function, that is the objective function which is there, which is given, along with certain constraints. Okay. So the constraints need to be checked with, and we need to, if any pre-assumed constraint, that is in our optimization problem, what is the pre-assumed constraint which is there? That is the non-negativity constraint. Okay. So we'll be checking with the non-negativity constraint too, and based on the non-negativity constraint, we'll be adding, right? In addition to what are all the constraints which are available, we'll be adding another one constraint, that is the pre-assumed constraint. Even though it is not given, we'll be applying that. Okay. So afterwards, what we are going to do, we'll be generating the new solution. Okay, by the use of both the things. Now we'll be computing another objective function. If it is not an optimal solution, we'll be computing a new objective function. Okay, and based on the objective function, we'll be checking with the convergence. Okay, so the convergence, in the sense, what we'll be doing in the previous cases, at first when we are checking with the integer programming, what is the convergence there? We'll be checking whether it is feasible or not. If it is feasible, then what we'll be doing, we'll be proceeding with. If not feasible, then we'll be stopping there. That will be the convergence. Okay, convergence check which we'll be using. Afterwards, what we are supposed to do, we need to, if it is meeting the thing, then we'll be going for the finding the optimal solution for the variables as well as the objective function which is given. Okay, so that is how we'll be proceeding with. Now we can see about what are all the search algorithms which are available. Okay, the search algorithms which are available are direct search algorithm as well as indirect search algorithms. Okay, in the case of the direct search algorithms, it will be considering only the objective function and it will be proceeding. The partial derivatives of the objective functions are not considered. Okay, that is how it is done in the case of the direct search algorithm. As in the case of indirect search algorithms, we will be considering the partial derivatives too for the objective function, and we will be proceeding it. Okay, so the direct search algorithm is known as non-gradient or the zeroth order method, and indirect search algorithms are known as the descent method. Okay, that is how we will be classifying the search algorithms. Now what we are supposed to do, we need to go on with the direct search algorithms. Already I told that what is direct search algorithm, only with the help of the objective function we will be making use of it and we will be searching. Okay, that is the direct search algorithm. So in the case of the direct search algorithm, there are certain classifications. Okay, there are at about 6 classifications based on, that is in the direct search algorithms, and we are going to see one by one. Okay, the 6 classifications are random search method, grid search method, univariate method, pattern directions, Rosenbrock's method, as well as the simplex method. Okay, so these are all the certain classifications of the direct search algorithms. Now we can see one by one. The first one is the direct search method. Okay, sorry, random search method. In the case of the random search method, what we will be generating? We will be generating a trial solution for the decision variables. Okay, we will be making a trial solution for the decision variables. Based on that, we will be having three classifications. Okay, the three classifications of the random search method are random jump, random walk with direct exploitation. Okay, so these are all the types of random search method. Okay, or the classifications of random search method. Okay, in the case of the random jump, what it will be doing, it will be generating huge number of data points. Okay, it will be generating huge number of data points. It will be assuming that the uniform distribution of the that is the decision variables, and it will be selecting the best one which is there. In all the cases at about, we will be selecting any one of the thing that will be the best. Okay, that is how we will be making, and we will be resulting at the end of each and every search. So in the case of the random search, what is the case? It will be generating huge number of data points, and it will be assuming the uniform distribution of the decision variables, and it will be selecting the best one in the case of the optimization, for the optimization. Okay, that is how it is done in the case of the random jump. The second thing is the random walk. Okay, so in the case of the random walk, what it will be doing, it will be also generating a trial solution, but in the previous case it will be assuming that it is the uniform distribution. Okay, but in the case of the random walk, what it will be doing, it will be generating a trial solution with the sequential improvements. Okay, sequential improvements, which are that is sequential improvement using the scalar step length as well as unit random vector. Okay, two things. Based on two things, it will be making the sequential improvements. That is, the first one is based on the scalar step length, and second one is it is based on the unit random vector. Okay, so that is how the random walk is taking the decision. Okay, and the third thing is the random walk with direct exploitation. Okay, in the case of the direct that is random walk with direct exploitation, it is the improved version of the previous one, that is the random walk search. Okay, so here the successful direction of the generating trials is taken into consideration along with its direction. Okay, so in the previous case, what it will be doing, it will be generating a trial solution with the sequential improvements, right, based on two things, that is the scalar step length as well as the next one is unit random vector. Okay, so here what it will be doing, it is to the same, but what it will be doing, in addition to that, the steps which are taken will be taken along with its direction. Okay, that is the difference than the random walk search. Okay, and the next search method is grid search method. Okay, in the case of the grid search method, what it will be doing, it is the methodology which will be involving the setting up grids in decision variables. Okay, so it is a methodology which will be including the setting up of grids in the decision variable. So based on the grids which are formed there, it will be taking the decisions. Okay, so here the objective functions are evaluated at each and every grid point. So each and every grid points will be considered for that is the evaluating the objective function. Okay, and the next thing is the point which is corresponding to the best objective function value is considered as the optimal solution. So I told that in each and every cases, almost they will be using that, they will be choosing any one of the best solution for the optimum. solution. Okay, best case for the optimum solution. So here too, it will be the point which is corresponding to the best objective function. So here what we'll be doing, each and every grid points will be chosen, and based on the grid points only, they'll be choosing the objective function. So among the objective functions which is in the grid 2, they'll be choosing any one that will be the best one, and that will be our resulting optimum solution. Okay, so here what is the drawback? That is, if the number of grids is getting increased, then the number of decision variables is also getting increased, right? So it is hard enough to find what is the optimum solution for a particular thing, and based on the objective function which is chosen only, we will be choosing the best solution. So that is a hard thing to find when we are going for this grid search, and when the grid size, that is the grid point, is getting increased, this will be the drawback. So better thing is, when we are having grid method, is also best when we are having a certain grid points. Okay, if the grid points are getting increased, then it will be a that is a disadvantage when we are going with the grid search method. Okay, that is in the case of the grid search method. Next is univariate method. It is univariate method. Okay, so univariate method is, it will be generating a trial solution for one decision variable, keeping all others fixed. Okay, so it will be also generating a trial solution. In the previous cases, they will be choosing the grid points. In the previous, it will be generating based on two things, right? So that is how it will be. But here, it will be taking the that is trial solution, generating the trial solution for a thing, keeping, that is, all others fixed, and the one which it is processing, that alone will be taken for considering the or making the decision. Okay, so that is how it will be generating the trial solution. So here, how the best solution is taken. So here the best solution for each of the decision variable is chosen, keeping all other constants which are obtained from the given thing. Okay, so best solution for each and every decision variable is taken. There, in the previous cases, they will be choosing any one of the decision variable which is the best one. Okay, here it is not so. It will be choosing the best solution for each and every decision variable by keeping all others as a constant thing which are obtained from the given case. Okay, and here too, how that is goal is to reach the, so before finding the optimum solution, we need to reach the convergence, right? So for making the convergence, what it will be doing, it will be iterating the process again and again until it is reaching the convergence. Okay, so that is how it will be in the case of the univariate method. Okay, the next method which we are going to see is the pattern directions. Okay, so the pattern directions, as in the case of the pattern direction, what will be the case? That is, it will be same as that of the previous method, and what it will be doing. So in the univariate method, the search decision is same as the coordinate access decisions. Okay, in the previous method, that is in the univariate method, the search decision which is taken, that will be same as that of the coordinate access which are there. Okay, so it will be making the convergence a process. The convergence process is getting slower as each and every time it need to check with the coordinate access direction. Okay, but in the case of the pattern direction, the search is performed not based on the coordinate direction, but along to the direction of the best solution. Okay, in the previous cases, the best solution is found. How the best solution is found? It is not a single best solution, right? So each and every, that is for each and every decision variable, we will be having certain, yes, each and everything we will be having certain decision variables, because each and every decision is taken based on keeping all other variables as a constant one, right? So for each and every objective function or each and every variables, we will be having a best solution. But in the case of here, it is not so. Okay, there it will be going through the direction of the coordinate axis. But in the case of the pattern direction, what is the case? It will be performed, the searching is performed not along with the coordinate direction, but along with the direction towards the best solution. So based on the best solution only, the searching is done. Okay, now here we are having certain popular methods which are used based on that is for the pattern direction. The popular methods are Hooke and Jeeves method as well as Powell's method. Okay, two methods are there, that is Jeeves, that is Hooke's and Jeeves method as well as Powell's method. Okay, that are all the two methods which are familiar when we are going for the pattern direction. Okay, in the case of the Hooke as well as Jeeves method, it will be using the exploratory move as well as pattern move. Okay, it will be using the explorative move as well as the pattern move. But in the case of the second method, that is the Powell's method, it will be using the conjugate gradient. Okay, it will be using the conjugate gradient. That is how the pattern directions are made. Okay, the next thing is Rosenbrock's method. Okay, Rosenbrock's method. So it is also known as Rosenbrock's method of rotating coordinates. Okay, it is also known as Rosenbrock's method of rotating coordinates. So it is the modified version of Hooke's as well as Jeeves method. So in the Hooke's as well as Jeeves method, what it will be doing? It will be using the exploratory move as well as the pattern move. Okay, here too it will be using the same way, but a slight variation is there. What is the variation is? The coordinate system which is there is rotated in such a way that the first axis always orients to the locally estimated direction. Okay, they will be estimating a local direction for the best solution. Okay, as like pre-assuming. Okay, they will be predicting that this may be the best solution. So according to the best solution which is there, what it will be doing? The coordinate system which is there is rotated in such a way that the first axis always orients to the locally estimated best solution, or the estimated direction of the best solution. Okay, and all the other axes which are there, that will be made mutually orthogonal and the normal to the first one. Okay, it need to be normal to the first one and mutually orthogonal to the all the axes which are there. Okay, that is how the things are made, and from which they will be finding the solution. Okay, so in the case of the Rosenbrock's method, or else the Rosenbrock's method of rotating coordinates, what it will be doing? It will be also similar. It is also similar to the Hooke as well as Jeeves method. In this method, what it will be doing? It will be considering the Hooke's as well as Powell's method in such a way that the exploratory move as well as the pattern move is carried out. But in the case of which, what we will be doing? In the case of the same, it will be taking the coordinate system, which will be rotated in such a way that the first axis always it is orienting to the pre-assumed or the predicted best solution which is assumed. Okay, and the all the axes which are there that will be made mutually orthogonal, and it is also normal to the first one. Okay, that is how it will be made, and they will be finding the best solution among all the coordinates which is there, and it will be finding the optimal solution. Okay, next method is the simplex method. Okay, so in the case of the simplex method, it is the conventional direct search algorithm. Okay, it is the conventional direct search algorithm, in the case of which what it will be doing, it will be using reflection, contraction as well as expansion. Okay, it will be using reflection, contraction as well as expansion. Okay, that is the three ways in which they will be making the movement in the case of the simplex method. So for which what we're doing, how the best solution is taken, that is here the best solution which will be lying on the vertices of the geometric figure in which the n-dimensional space is made, and that is it will be in the case of the n-dimensional space, that is normally when we are having vertices as well as edges, what we will be doing, we will be having n number of edges. Okay, sorry, n number of vertices. Okay, consider that if we are having 2 or 3 points. Okay, so when we are supposed to join 2 points, the vertices will be 2. Okay, and in between to that we will be drawing a single line, right? Drawing a line between the 2 points or the 2 vertices which are there. So when it is having n plus 1 points, then it will be containing n number of vertices, right? So that is how it is mentioned here as the best solution which will be lying on the vertices of the geometric figure, in which it will be containing n dimensional space which is made up of n plus 1 points. Okay, that is how we will be finding the best solution. Okay, the method which will be comparing the objective function values at the n plus 1 vertices and moves towards the optimum point iteratively. So here too we will be having the iteration, and based on the iteration which is made, what we will be doing, we will be finding the optimum solution according to the points or the moves which are happening. Okay, that is how we will be making the optimum solution based on the simplex method. Are you getting me? So these are all the things in which we will be making use of. So again we can yes. So again we can go on with the types. So in the types of direct search algorithm, how many types are there? 6 types are there. Okay. So the 6 types are random search method, grid search method, univariate method, pattern direction, then Rosenbrock's method, as well as Rosenbrock's method of rotating variables, as well as simplex method. Okay. In the case of the random variable, what it will be doing? In the case of the random search, what it will be processing? It will be generating the trial solution for the decision variables, and The classification of that are random jump, random walk, as well as random walk with direct exploitation. Okay, in the case of the random jump, what it will be doing, it will be generating huge number of data points, assuming that the uniform distribution of the decision variables, and it will be selecting the best one among them. Okay, the second thing is the random walk. In the case of the random walk, what it will be doing, it will be generating the trial solution with the sequential improvements which are there using two things. What are all the two things? Scalar strip, that is scalar step length, as well as unit random vector. Okay, and in the case of the random walk with direct exploitation, it is the improved version of that is random walk search, in which the successful direction of the generating trial solution is found out, and the steps which are taken, which will be along with the direction of what is there. Okay, that is in the case of the first, that is the random search method. Second one is the grid search method. As in the case of grid search method, what is the case? The methodology which will be improving the setting up of grids. Okay, so based on the setting up of grids, which is based on in the decision variable, what it will be doing, it will be choosing the objective function values which are evaluated at the grid points. Okay, so based on the grid points only, the objective function is taken, and the objective, among the objective functions, it will be choosing the best one. So for which, what we are supposed to do, we need to choose, that is calculate the optimum solution from each and every points, grid points, and we will be taking, considering, or else resulting with the optimum solution. So for which, what we are supposed to do, we need to calculate this. And what is the disadvantage when in the case of the grid search method? The disadvantage is, that is, then if the number of grid points is getting increased, then it is hard enough to find the number of decision variables. So it will be automatically increasing, and the optimum solution which need to be found is a ethical one. Okay, so when it is having minimum number of grid points, that is advisable when we are going with the grid search method. Okay, next is the univariate method. In the case of the univariate method, what will be doing, it will be generating the trial solution for that is one decision variable. If that is made, then all other variables which are there, okay, that will be kept fixed. Okay, that is in the case of the direct search algorithm. So how here the best solution is found? That is, the best solution is found for each and every decision variables, finding, that is keeping all other variables as a constant one. Okay, so whole process which will be generating iteratively, and that is till the convergence is getting convergence is arrived, we need to do it again and again. Okay, that is in the case of the univariate method. Next is the pattern directions. So in the case of the pattern direction, in the previous, that is in the univariate method, what is the case? We will be having the search direction which will be same as that of the coordinate axis direction. But here, what will be the case? So there, the process which are based on the convergence, that will be slow. So to improve this, we will be going with this pattern direction. In the case of the pattern direction, the search is performed not by the coordinate axis, but with the direction towards the best solution which is there. Okay, so here two methods are a popular thing, that is Hooke's as well as Jeeves method, and the next one is the Powell's method. As in the case of the Hooke's as well as Jeeves method, what are all the things which are used? It will be using the exploratory mu as well as pattern mu. Okay, in the case of the Powell's method, it will be using the conjugate gradient. Okay, the next thing is the Rosenbrock's method of It is also known as Rosenbrock's method of rotating coordinates. Okay. It is the modified version of the Hooke as well as Jeeves method. So in this, what we'll be doing, we'll be coordinate the systems in such a way that it will be rotated in such a way that the first axis which is there, always it is orienting locally to the estimated or the predefined or pre-assumed best solution. Okay, and all the axes which are there, that will be mutually orthogonal to that, and it is normal to the first axis, first one which we have chosen. Okay, first one which is, and the next thing is the simplex method. As in the case of the simplex method, what we'll be doing, we'll be have it is a conventional direct search algorithm, and the best solution which is there, it will be lying on the vertices of the geometric figure in n plus 1, that is n dimensional space, which is made of n plus 1 number of points. Okay, so the method which will be comparing the objective function values at the n plus 1 vertices, and it will be moving towards the optimum point iteratively. Okay, the movement of the things are three movements are there, right? Reflection, then contraction, and expansion. Okay, these are all the direct search algorithms which are there when in the case of the direct search method, which is in the unconstrained, so that is methods. Okay, okay, so the next day we can see another unconstrained method in the fourth module. Okay, so don't forget to submit the assignment. So you submit the assignment with date. So how, whether you have submitted previously, will you type or will you, whatever it may be, okay? You can type it and you can produce it, or else you write the same solution in the paper or whatever it may be, and you scan it and upload it. Okay, that is how we are supposed to submit. So submit within time.
When the virtual screen is released, the simulated force will be slightly larger than the real screen which would produce. Okay, so that what will happen? The ball will become active and more passive. Okay, and it almost will give a feel of the real ball. Okay, so this is how a ball is created.
Yes, I'll provide you the
Reality.
Google Classroom code. Wait.
What will be doing is like that will be a surface penetration thing. Okay, to be calculated using the velocity. Okay, so if there is negative velocity, then it means the object is moving towards the wall. If there is positive velocity, then it means the object is moving away from the wall. Likewise, we create the meaning of the wall. Okay. So, is it understandable? Or do you guys have any doubts?
Yes. So I have shared the GCR code. You can take from this. I have posted the video with the PPT. Okay, so you can take the question from there and you can do it. So now kindly answer your attendance, please.
And the seven, 18 001
Is Hansi attendance 2001?
Present, ma'am.
Harrison Stephen
Present, ma'am.
1001. Jelady Preetham
Present, ma'am.
2,
Present, ma'am.
3,
Present, ma'am.
4, sorry, 10,
Present, ma'am.
12. Joel Sam 15,
Present, ma'am.
16,
Present, ma'am.
17,
Yes, ma'am.
33,
Present, ma'am.
36,
Present, ma'am.
37,
Present, ma'am.
40, 40, it's not here. Ashish Kumar 43,
Yeah, ma'am.
56, 56,
Yes, ma'am.
58,
Present, ma'am.
64, Ashley John 64 is not here. 69,
64 in chat box.
77,
Present, ma'am.
78,
Present, ma'am.
81,
Present, ma'am.
87, 87, Abhinav is not here. Then 93,
Present,
93,
ma'am.
94,
Yes, ma'am.
101, Melvin
Present, ma'am.
2.
Ma'am, 1064 gave his attendance in the chat.
Wait, those who haven't answered, wait till the end. Okay. 107, Rajat Nair.
Present, ma'am.
109, Rishabh Nair. Are you here? No. 1132,
Yes, ma'am.
1143,
Yes, ma'am.
45,
Yes, ma'am.
54,
Yes, ma'am.
55,
Yes, ma'am.
70, 70,
Present, ma'am.
70 it is there. 72,
Present, ma'am.
77,
Present, ma'am.
80,
Present, ma'am.
85, 85, Lagiri, 86,
Yes, ma'am.
85 present, ma'am.
86,
Yes, ma'am.
87,
Yes, ma'am.
88,
Yes, ma'am.
91,
Present, ma'am.
94, Jerlin Lijo.
Present, ma'am.
Are you here?
Yes, ma'am.
Okay, 200, Ruddi,
Present, ma'am.
203,
Present, ma'am.
5,
Present, ma'am.
7,
Present, ma'am.
8,
Present, ma'am.
13, Kevin Paulson,
Present, ma'am. Present.
16, 16, Peter Rajkumar, 19,
Present, ma'am.
35,
Present, ma'am.
44,
Present, ma'am.
45, 45, Harish, 2002, Ruhan,
Here, ma'am, present.
3,
Present, ma'am.
4,
Present, ma'am.
5,
Present, ma'am.
6, Paul Jabbar Selvin Raj, 11, Monica, 12, Kumaresan,
Ma'am. Present, ma'am.
13,
Present, ma'am.
15.
Present, ma'am.
So absentees, please make a note of it. Now you can tell whoever is 1012. Joel Sam not here. URK 19 CS 1040. Ashish Kumar, not here.
Ma'am, he kept in chat box.
Chat box, okay. 1064.
Ma'am,
Ashley,
even he gave it in chat box, ma'am. Ashley is first.
Ashley. One 1087. Abhinav, not here, right? 1109. Rishabh Nair, not here. 1185.
Present, ma'am. 1185 present, ma'am.
Okay, ma'am. 1111. 1216. 1216. Peter Rajkumar, not here. 245. 1245. One, 2, 4, 5. Harish Abhishek, not here. 2006.
Ma'am, he gave in chat box, ma'am.
Who?
Selvin, 2006.
Pal Selvin Raj. Okay. Okay, ma'am. So absentees. 19 CS 1012, 1087, 1109, 1216, and 1245. Am I right?
Ma'am, the classroom link that you shared,
Okay.
is it the
Yeah,
same
I
one
shared.
that Abhishek sir uses? The same classroom?
Yeah, same, ma'am.
Nothing has been posted since July 26, ma'am.
It is not. Oh, maybe the not the same.
It goes to the same classroom, ma'am.
Is it sure? Today I posted, uploaded the assignment problem.
There is nothing, ma'am.
Okay, I'll check it. Okay.
And the classroom link which you shared, it goes to Abhishek sir's class only.
Okay. Wait, just a minute. Okay, I'll check to it. Okay. I can give you later. By today, I'll post everything. Okay, thank you, ma'am.
Okay, ma'am.
Ma'am, again will you post the GCR code, ma'am?
In that?
GCR code you will post again, ma'am. The one you given was wrong.
That is not wrong, ma. It is moving to the same. I'll check it. Okay. I have uploaded, but it's not at uploaded, it seems.
It is showing batch 3, ma'am.
Okay, I'll check it and let you know. Okay.
Oh, thank you.